So these are the essential questions for this week. We already did module 2.2, which was on solving absolute value equations, right? We're gonna head into solving absolute value inequalities, okay? And there's only a slight difference there, and we're gonna dive into that today. The two questions that we are going to answer. What is the main difference between solving an absolute value inequality and absolute value equation? Main differences. Main differences between solving absolute value inequalities and solving absolute value equations. And for part B or question number 2 is, how do I solve an absolute value inequality algebraically? All right, so those are our essential questions for this lesson. And let's get started. So remember the absolute value definition, right? It means distance away from zero. Okay, and we think number line. The only difference, right, is an inequality now. So if I have, I'm gonna go back and forth. If I have x is greater than absolute value of x is greater than 2, or absolute value of x is less than 4, right? My first step, class, is to try and graph x, absolute value of x is equal to 2. Okay, where is that? Where is x equal to 2? Absolute value of x. At 2 and -2, right? Yeah. But now if you think about it, just use your brain and think, I want distances, right, away from 0 that are greater than 2. If it's greater than 2, what distance from -2 is greater than 2? What distance away from 0 from -2 is greater than 2? Is it going? So I'm at -2. The distance here is 2, correct? Yeah. What number would make this distance greater than 2? I'm at -2. If I move it to -3, if I move it to -4, if I move from -5, if I move to -6, if I move to -7, and so on and so forth, correct? Yeah. So from this point on this way, these distances away from 0 is greater than 2, correct? Yeah. Hold on, Justin. And how about 2? I'm at 2. I want things that are greater than 2. So this circle, class, is actually going to be what? Open. Okay? Because it equals 2, right? So at what distances here is going to be greater than 2? If I move to 3, if I move to 4, if I move to 5, if I move to 6, if I move to 7, right? And so on and so forth. So this would represent all of my distances that are greater than 2. It would be an open circle at 2 and -2 because it's just greater than, and it would move away from each other. Okay? Make sense? Now, if I have this, how do I write the inequality? How do I represent this in an inequality? X is greater than, less than? Huh? How do I represent this arrow in terms of an inequality? X is less than -2, right? Yeah. The number X, whatever is in my absolute value, I forgot absolute values here and here. Yeah. How would I represent this in an inequality? X is greater than 2, right? And that's true because if X is 3, it's a part of this a part of this interval, and that's greater than 2. If it's 4, it's greater than 2. 5 is greater than 2. 6 is greater than 2, right? Here, -4 is less than -2. -5 is less than -2, correct? Yeah. So then that would be your answer with an or. This is an or statement because it goes away from each other. Okay. Let's try and do the same thing here with X is less, absolute value of X is less than 4. Yes. Okay. So if absolute value of X is equal to 4, it would be at -4 and 4, correct? Yeah, if it's equal to. But I want things that are the distance away from 0 is less than 4. The distance away from 0 is less than 4. So what numbers am I talking about? The numbers that are in between, right? Because all of these distances are less than 4, right? The distance away from 0 is less than 4. Okay? So this right here has only one inequality. X would be in the middle, right? This number would be on my left-hand side. This number will be on my right-hand side. And all I'm going to do is just put less than sign. This means that X is between -4 and 4. Okay? This is an and statement. This is an or statement. Okay? And later, I'm going to tell you why that's important. All right? And we're just going to be solving these guys. Same steps as equations, right? We're going to isolate the absolute value on one side. Preferably, isolate the absolute value on the left-hand side. Okay? Because
you want X.
Oh.
You want to make the equation.
Yeah, whatever the absolute value is. Okay? So I wrote down the steps here for you guys. Step number 1 is isolate the absolute value on the left-hand side of the equation or the inequality. Okay? Rules to remember when you are dealing with inequalities. If you multiply or divide by a negative, then just flip the sign. If it is less than or equal to or greater than or equal to, they are closed circles, right? The closed and open circles matter here, okay? Remember, if it's open, then it's going to be less than or greater than. If it's closed, that means that it's less than or equal to or greater than or equal to because you're equaling that number. Okay? And then we'll talk about 2 and 3 in a little bit. So I'm going to isolate the absolute value first. So by isolating it, I'm going to add 10 to both sides. So it's absolute value of x plus 4 is less than or equal to 8. Correct? Now I have my absolute value isolated on the left-hand side of the equation. Okay? All right? Step number 2 is to identify the inequality and think about what it means. So remember, if this is isolated, what we love to do is, instead of saying absolute value of x plus 4 is less than or equal to 8, I'm going to put the distance. I'm going to think distance away from 0. Okay? The distance away from 0 is less than or equal to 8. That means on a number line, 0, -8, and 8, correct? Since it's less than or equal to, it's going to be these guys here, right? Because it's equal to. And I want distances that are, or the distance away from 0 that is less than 8. Meaning 7, 6, 5, 4, 3, 2, 1, right? And then distance of 1, if I'm at -1, -2, -3, -4, -5, -6, -7, -8. Because all of those distances are less than 8. Right? All of these guys here, let me switch up my color. All of these distances here in blue are all less than 8. Right? Yeah? At -7, -6, -5, -4. Correct? Yeah? So what we have to do, I'll get to your questions. Okay? Is whatever is in my absolute value, x plus 4, right? And then on my left-hand side, I'm going to put -8. My right-hand side, I'm going to put 8. And then put less than or equal to, less than or equal to. Okay? My next step is to solve it. So I'm going to subtract 4 on all 3 sides of the equation. This is -12 is less than or equal to x, which is less than or equal to 4. And that's my answer. Okay? If you would have to graph it, right? 0, let's make this -12. Let's make this 4. Close circles here and here, and it's in between. Okay? Yes. Is 0 part of the answer? Uh-huh. No, this number line helps me with that equation. And then from that equation, we just have to solve. Okay. Now, if you look at number 2, the step number 2. I didn't get that. This is a shorthand of what you guys need to know. If you isolate the variable or isolated the absolute value on the left-hand side of the equation, right? And the symbol is less than, then it's less than. So it's going to be an and statement. Okay? That makes sense? If you isolated the absolute value on the left-hand side of the equation, and it's greater than 8, greater than or equal to 8, right? then you're going to think or greater, or it's going to be an or statement. So it's going to be pointing in opposite directions. Okay, that's a shorthand for what we're doing here. Okay. All right. So towards the end of this lesson, I'm just going to use that shorthand. Okay, once we get the hang of solving equations, inequalities. Okay. Next one, we have this. Huh? Okay. So here I want to isolate my absolute value on my left-hand side of the equation, right? So I'm going to divide this by 3. Divide that by 3, divide that by 3. So absolute value of x minus 7 is greater than or equal to 3. 9 divided by 3 is 3. Okay? So if the absolute value is isolated, again, I think of the definition, the distance away from 0 is greater than or equal to 3, right? If I put it on a number line and think of it on a number line, the distance away from 0 is greater than or equal to 3. Since it's equal to, it's going to be a closed circle here and here. And it's going to be moving away from each other, right? Because this distance is, let's say that's -4. -4, the distance away from 0 is 4. And it's greater than 3. Yeah. And so on and so forth. You guys can think of it like that. So on my left-hand side of the inequality here, how do I represent that in terms of an inequality? X minus 7 is going to be less than or equal to -3, right? Like -4 is less than -3, correct? Or x minus 7, what's in my inequality, is greater than or equal to 3, like 4. Right? 4 is greater than or equal, greater than 3. So it fits in that interval. Correct? And then what we're going to do is just solve it. So we're going to add 7, add 7. We can add 7 here. Add 7 here. So x is less than or equal to 4, or x is greater than or equal to 10. Right? On a number line, 0, 4, and 10. Close circles because they're equal to. X is greater than 10, meaning I'm going to go to my right. X is less than or equal to 4, which is meaning I'm going to go to my left. Okay? So this one here, right? We have to isolate my absolute value. So I'm going to subtract 8 on both sides, making this 5 absolute value of x minus 3 is greater than or equal to 10. Divide by 5, divide by 5. So absolute value of x minus 3 is greater than or equal to 2, correct? So I have my absolute value isolated. So I'm going to think distance away from 0 is greater than 2. That means, class, at 2 and -2, since it's greater than, the distance away from 0 is greater than, it's going to go away from each other, right? Because the distances away from from that point is greater than 2. Okay? So I have two equations. X minus 3 is less than or equal to 2, or x minus 3 is greater than or equal to, or negative 2, I mean, to 2, right? Just solve it simply by adding 3 to both sides. Adding 3. X is less than 5, less than or equal to, not 5. Less than or equal to 1, or x is greater than or equal to 5. Okay? And you guys can graph this. 0, 1, 5, less than or equal to, so it goes like that. Greater than or equal to 5, it's just going like that. Okay? So it's imperative that you guys think of the definition for absolute value. Okay? Let's isolate that guy, right? Isolate the absolute value. Add 8, add 8. So 3 absolute value of x plus 9 is less than 15. Divide by 3, divide by 3. Absolute value of x plus 9 is less than 5. If the distance away from 0 is less than 5, at negative 5 and 5, I know the distance is 5, right? Those guys are going to be open circle because it's just less than. If it's less than 5, I want something that's going from 5 to 0, right? And negative 5 to 0 because that's the distances that are less than 5, right? At like negative 4, or like positive 3, or like negative 1, or like positive 1, right? They all have distances away from 0 that are less than 5. So it's an AND statement, okay? So x plus 9, if it's an AND statement, I always put whatever's in my absolute value in the middle and go negative 5 and positive 5 and just put less than sign. Okay? So I'm going to subtract 9 on all 3 sides, here, here, and here. So it gets negative 14 is less than x, which is less than negative 4. And then when you graph this, 0, negative 4, negative 14, open circles because it's just less than and right in between. Okay? Questions on this? No? So you guys see how it's always going to be if it's a less than statement, right? After we isolate it, it's going to be an and statement. Okay? They're always going to be linked. If your absolute value is on the left-hand side. Okay? And if it's a greater than or equal to or just greater than statement, it's going to be an or statement, so then things are going to pop out that way. Okay? All right, so once we have this one, let's try this really quick. Add 8 to both sides. So we have negative 2, absolute value of 3 minus 3x is greater than negative 6. Divide by negative 2 on both sides. So we have absolute value of 3 minus 3x is greater than 3. Did I do something wrong? Yeah. Yes. This symbol here flips, correct? We flip it because we divide it by a negative. Okay? If you divide or multiply by a negative, you are going to flip the sign. Okay? So it flips. So the absolute value, right? The distance away from zero, because it's isolated, I can say the distance away from zero is less than 3. Less than, it's an and statement, correct? So 3 minus 3x is going to be in the middle. 3 is going to be on my right-hand side. Negative 3 is going to be on my left-hand side. Less than or less than, just less than. Not less than or equal to. Less than. Okay? Take that out. Subtract 3 on both sides or on all 3 sides. Negative 6 is less than negative 3x, which is less than negative 1. Divide by negative 3, divide by negative 3, divide by negative 3. 2. Wait. Oh, it's 0. Huh. Good catch. Okay. So 2 is greater than x, which is greater than 0, right? I flipped the sign, flip it back. 0 is less than x, which is less than 2. This makes sense because on a number line, open circles and right in between. Okay? All right. And that would be your answer here. Okay, any questions here? No? Let's do this one. Okay, the last one of the day. Okay, so here I'm gonna isolate my absolute value. So negative absolute value of 9 minus 2x is less than negative 7. Divide by a negative 1, divide by a negative 1. Absolute value of 9 minus 2x. Flip the sign, 7. And then next up would be, it's a greater than, right? It's an or statement. So what I'm going to do here, 9, or I'm going to put it up here. 9 minus 2x is less than negative 7. Switch the signs. Or 9 minus 2x is greater than 7. If you don't understand what I did, right? Then just go back to the number line. Okay? Negative 7, 0, 7. Open circles. I want things that are the distance that are greater than 7. So it's this way and that way. Okay? And then we just solve it. Minus 9, subtract 9, subtract 9. Minus 2x is less than negative 16. Subtract 9, subtract 9. Negative 2x is greater than negative 2. Divide by negative 2, divide by negative 2, divide by negative 2, divide by negative 2. X is dividing it by -2, flip the sign, +8. X is less than 1, right? So here we have 0, 1, and 8. Anything that's less than 1 or greater than 8, right? It's an OR statement. And that's my answer. Cool? Yeah? Understand that? Okay. That's the lesson for today. That is solving inequalities.